Today, our topic field effect transistors. So, last class was seen transistors, compensation techniques, or amplifiers, emitter, follower. These things we seen. So, in first unit, we seen diode as a semiconductor device. In second unit, we seen transistor as a semiconductor device. In third unit, we have field effect transistor. FET is also a semiconductor device. Okay. Today we will see in detail about field effect transistor. So FET is a field effect transistor. It is another semiconductor device like BJT or transistor. So which can be used as an amplifier or switch. BJT can be used as an amplifier or switch. Similarly, FET is also used as a amplifier or switch. Okay, like BJT, FET is also a three-terminal device. FET is also a three-terminal device like BJT. Okay, FET is a field effect transistor. It is a three-terminal device. However, the principle of operation of FET is completely different from the BJT. So both are semiconductor devices and both are having three terminal devices, but the operation is different. So FET operation is different and BJT operation is different. So the name field effect is derived from the fact that the flow of current through the conduction region is controlled by an electric field. That is called field effect transistor. So we will see different types of transistors are there. We will see one by one. So this is FET. So FET can be divided into two types. One is JFET. JFET means junction FET. JFET. Another one is MOSFET. JFET and MOSFET. So MOSFET can also be called as IGFET. IGFET. IGFET or MOST. So IGFET is nothing but insulated gate FET. IGFET is nothing but insulated gate FET. Okay. And MOST means metal oxide transistor, metal oxide silicon transistor. This one is metal oxide silicon transistor, insulated gate FET and MOSFET. Here MOS means metal oxide semiconductor field effect transistor. IGFET means insulated gate field effect transistor. MOS means metal oxide silicon transistor. So all are same. So FET can be categorized into two types. One is JFET, junction FET. Other one is MOSFET. Okay. Again, JFET can be categorized into two types. One is N-channel JFET, N-channel JFET. Second one is P-channel JFET. N-channel JFET and P-channel JFET. Okay. So MOSFET is also categorized into two types. One is depletion. One is depletion MOSFET. One is depletion MOSFET. Depletion MOSFET. Other one is enhancement MOSFET. Enhancement MOSFET. Enhancement MOSFET. So FET is two types. One is junction FET, other one is metal oxide semiconductor FET. Again, JFET can be categorized into two types. One is N-channel JFET, another one is P-channel JFET. Okay, in MOSFET, two types. One is depletion mode and enhancement mode. So depletion MOSFET and enhancement MOSFET. So actually in BJT, it is a current control device. BJT transistor is a current control device. Here FET is a voltage control device. FET is a voltage control device. Why? Because output current is controlled by varying the input voltage. That's why FET is a voltage control device. So FET is a unipolar device. The current conduction is only by majority charge carriers, either holes or electrons. So FET is a unipolar device, whereas BJT is a bipolar device. Both electrons and holes exist in BJT, whereas in FET only majority carriers, either electrons or holes. So that is the difference. So it is a three-terminal device. So FET is a three-terminal device. So what are the three terminals of FET? Or namely, we call it as, first one is drain, second one is source, third one is gate. So these are the three terminal of a FET. First one is drain, source and gate. So this is in FET, whereas in BJT, what are the three terminals? Emitter, base, collector. Emitter, base, collector. These are in BJT. So these are in FET. So both are semiconductor devices. Both are having three terminals, but the operation of FET is different from BJT. So it is based on field effect in BJT in FET, whereas in BJT current conduction takes place based on majority and minority. There is no field effect. Okay, FET is more temperature stable as compared to BJT. We see in amplifiers, transistor amplifiers or BJT amplifiers, there is a disturbance because of temperature. Because of temperature, parameters are changes. If temperature is increases, like VB, beta, IC naught. If these things are changing, means the stability point is also changes. If stability point is also changes, means unfaithful amplification occurs at the output side. So that is the main drawback in BJT because of temperature. Here in FET is a more temperature stable. Even though temperature increases, this FET is stable as compared to BJT. So FET has very high input impedance and low output impedance. Typically the range of several mega ohms. So input impedance is several mega ohms. FET has higher input impedance than BJT. So this is the comparison. FET has a higher input impedance. So input impedance is high. Input impedance is high. So this one is low. Input impedance is low for BJT. So input impedance is high for FET and input impedance is low for BJT. Okay. So FET has a higher input impedance than BJT. So FET is preferred in amplifiers. FET is preferred in amplifiers, whereas high input impedance is required. So FET is used as a high input impedance. So whenever we require high input impedance in amplifier, we prefer FET. Okay. So FETs require less space than that of BJT. Hence, they are preferred integrated circuits. So in manufacturing of FET, we require less space. So less space for FET. Less space for FET, whereas high space, big space is required for BJT. That's why in integrations devices, VLSI technology, we prefer only FET because it requires less space. So remaining space we will add some other component also. So this is the main advantage of FET. It requires less space so that it can be used in VLSI technology. So integration of all components into chip, at that time we use FET instead of BJT. Okay. So first we will see FETs are two types. One is JFET, another one is MOSFET. So we will see first JFET. JFET is nothing but junction FET. JFET is nothing but junction FET. So again, depending upon the majority carriers, JFET can be classified into two types. One is N-channel JFET, another one is P-channel JFET. So in N-channel JFET, with electrons as the majority charge carriers, P-channel JFET, holes are the majority charge carriers. See, you can observe, first one is junction FET is two types. One is N-channel. N-channel JFET. N-channel JFET. Next one is P-channel JFET. See, in N-channel, so FET is a unipolar device. So either electrons or holes. But here N-channel JFET, what is the majority charge carrier? N for, already I told in BJT, N for negative. Negative means electrons. So N-channel JFET, the majority charge carriers are electrons. The majority charge carriers are electrons. Okay. P-channel JFET, the majority charge carriers are holes. You have to remember P for positive, P for positive. Positive means holes. So the majority charge carriers are holes. Okay, the majority charge carriers are holes. So now we will see the construction and the symbol of N-channel JFET. So first we will see the first one, the N-channel JFET construction and the symbol of N-channel JFET. So this is the construction and the symbol of N-channel JFET. I will explain this one. So first, so we know that FET is a three-terminal device. Okay. So these three terminals are namely we call it as gate. This one is source, and third one is drain. Okay. So you can observe this gate terminal and source terminals, both are same materials. Gate terminal and source terminal, both are same materials. See, this is the black dot, it is the gate terminal. This black dot, it is the source terminal. This is the gate terminal. These black dots. This is a gate P-type material. Gate is a P-type material. Again, we will see here source. Source is the N-type material, and here also drain is the N-type material. Okay, I repeat, gate is same material. It is a P-type material. So we are shorted from this line to this line. So it is the gate terminal. Both sides we are shorted. P-type material is a gate terminal. Next, upper portion we have this bar. This bar is a N-type. This N-type, and below this bar is a N-type. So this is the source terminal. This is the drain terminal. So total three terminals: gate, source, drain. Okay. In between, this is the N. So this is P. This one is P. So total this space, remaining space, this space is there. This space we call it as channel, N channel, because it is the N-type material. We call it as N channel. Okay. So this is the N channel. Okay. So the symbol of N channel JFET. So N channel JFET means the gate terminal is towards the circuit. So this symbol is towards gate. This one is the gate, drain, and source. So this terminal is the gate, G. This terminal is drain, and this terminal is source. So it is a three-terminal semiconductor device. FET is a three-terminal semiconductor device. This is the construction and symbol of N-channel JFET. So N-channel means channel must be N here. This is the channel. The space is all channel. If P channel means, so we have to use P-type material here N-type material. That is the difference. So it is a N channel means channel must be N-type material. This is the channel N-type material. Okay. So here source, three terminals are there. First one is source. This terminal is connected to the negative terminal of the battery. So the source terminal is always connected to the negative terminal of the battery. You have to note down in your notebook. So source terminal always connected to the negative terminal of the battery. Okay, that is the important point. So electrons which are the majority carriers in N-type bar enter into the bar through these terminals. Okay. So already it is a source is a N-type material. We are connecting to the N-type terminal to the negative terminal of the battery. So N-type having negative and the battery negative terminal having both are negative. So electrons are ripples. So electrons are ripples means electrons are flow through the source to drain. Okay. I repeat. So source is a N-type material here, N-channel JFET. So N source is always connected to the negative terminal of the battery. So both are negative means N-channel is having negative charge and battery terminal is also negative means both the ripples. Ripples means electrons are moved from source to drain, from bottom to up. Electrons are moving from bottom to up. So that is called source terminal. So what about drain terminal? What about drain terminal? This terminal, so this is the drain terminal. This terminal is connected to the positive terminal of the battery. So the majority carriers leaves the bar through the terminal. Okay. So source is connected to the negative terminal of the battery and drain is connected to the positive terminal of the battery. For example, this is a battery. So this is a battery. So positive terminal of the battery is connected to the drain and the negative terminal of the battery is connected to the source. So whenever positive terminal is connected to the battery, what happens? This is N. This is positive. Here it means electrons. This is holes means both are attracted So these electrons are moves towards this battery. So that means electron movement is from source to drain. Electron movement is from source to drain, but current is flowing from drain to source. That current we call it as ID. So I will explain in detail about operation of JFET. So just this is the how it appears N channel and P channel. Next, what is the other terminal? Gate. So this is the gate terminal. So this is the gate terminal. Both sides these bars are shorted. Both sides these bars are shorted. So gate terminal is a heavily doped P-type silicon. P-type silicon is diffused on both sides of the N-type silicon bar, by which PN junctions are formed. These layers are joined together and call it as JFET. So gate is heavily doped P-type material. So this is the P-type material. Okay. It is diffused on both sides of the N-type silicon bar. So this is the N-type silicon bar total. We are diffused P-type material into both sides. So PN junctions are formed. These layers are joined together and called as gate. So these are the three terminal description. Okay. Next, what is their other thing? So three terminals we discussed. What is the other thing? Channel. So in between there is a channel. So channel is the thin region between the two P gates. So channel is nothing but a thin region between the two P gates. So this is P, this is the two P gates. In between there is a space, we call it as channel. That region we call it as channel. Okay, since this channel is N-type bar, the FET is known as N-channel JFET. So the channel is a N-type bar. First this is the N-type bar, that's why we call it as N-channel. If it is a P-type bar means we call it as P-channel. Okay, so this is called as N-channel JFET. So this is just construction, how we will construct JFET, N-channel JFET. Now we will see how we will construct P-channel JFET and symbol. So this is the construction structure and symbol of P-channel JFET. So it is similar to N-channel JFET, just small modification. So in previous we have taken N-channel bar or N-type bar. Now we have taken P-channel bar. See, so total we call it as a P-channel bar. It is a bar, P-channel bar, a material. Just we are diffused N-type both sides, N-type both sides, and these are shorted. So we call it as gate terminal. And this terminal we call it as drain terminal. This drain terminal we call it as source terminal. In between, it is a P-type bar means it is having a this space we call it as a P channel. P channel. This space we call it as a P channel. Already we just now I discussed here also source, drain and gate. What do you mean by source here? Source is always connected to the negative terminal of the battery. Gate is always connected to the positive terminal of the battery, so that there is a movement of charge carriers from source to drain. If charge carriers are moving from source to drain means current will flow, ID current. So the current is called as drain current flow from drain to source. So charge carriers are flow from source to drain whenever connected to the battery. So current is flowing from drain to source. Okay. So gate is a heavily doped. Here in previous one, gate is a heavily doped P-type material. So now here gate is a heavily doped N-type material. Okay. N-type material. on both sides of P-type silicon bar. Okay, both sides of this is the P-type silicon bar. So this gate is a N-type material. Uh, we are diffused on the both sides of P-type silicon bar by which PN junctions are formed. These layers join together and called it as gate. These layers are joined together, we call it as a gate. So symbol, how we can remember this symbol means it is a P channel means the conventional current direction is out of the symbol or circuit. Okay. So in previous, the symbol is towards the bar. The symbol is towards the bar. In previous, this is the FET symbol. This is drain, source, gate. But arrow mark is towards the bar. Towards the bar means it is a N channel. So it is here towards the outside. Conventional current direction is towards the outside means it is P channel. It is easy to remember these things. So N channel means towards the bar. This is the bar towards the bar. P channel means out of the bar. So this is the difference between N channel and P channel JFET. This is the difference between N channel and P channel JFET. Now we will see in detail about operation of N channel JFET. Okay. So this now you can see it is a representation in a graphical way. Junction FET transistor, that means JFET transistor. So this one is N channel JFET because arrow conventional current direction is towards the bar. This is the P channel JFET. So you can observe colors. So this blue color is the gate. So both terminals are shorted. You can observe here. So this bar is P-type bar. This bar is N-type bar. So this color is N-type. This color is N-type substrate. So this is the P-type material, both sides P-type material. So this pink color, we call it as a N-type substrate or N-channel. N-type substrate or N-channel. So this is the N-channel JFET. Similarly, so these colors are interchanged from here to here. Just we interchange. So colors are changed. So this bar is P-type bar. P-type bar. Blue color means P-type bar. N-type material is the both sides. We have diffused N-type material and shorted. We call it as gate. So this is P-type material, P-type channel. This channel we call it as a P-type. So that's why name it is P-channel JFET. Okay. So field effect transistor look like this way. See, source, gate, drain. Source, gate, drain. We will see in lab, ADA lab. Source, gate, and drain. So this is symbol. P channel because arrow conventional current direction is outwards. Here conventional current direction is towards the bar means it is N channel. So terminals are drain, source, and gate. Three terminal device. Okay. So field effect transistors come in two main types. One is JFET and MOSFET. So now we will see the operation of N channel JFET. So this is the FET. This is the FET operation of N channel JFET. Why it is a N channel arrow mark towards the bar? That's why it is N channel JFET. Okay, understood this one? So this is the basic circuit operation of N channel. If you understand good manner, so remaining things are very easy. So you have to concentrate now. So this is the N channel JFET. So because arrow mark is towards the bar, Okay, so it is having three terminals. One is drain, source, and a gate. Okay, this is the gate terminal, drain terminal, and this one is source terminal. So in between voltage is there. So gate, this is the gate terminal, this is the source terminal, means there is a voltage VGS. So voltage at gate to source. So gate to source. Similarly, this is the drain terminal, this is source terminal, voltage is VDS. Drain to source voltage, gate to source voltage. So VGS is the gate to source voltage, VDS is the gate to drain to source voltage. So these are the batteries. So input side, this one is the input side battery and this one is the output side battery. So you can remember here, positive terminal of the battery is connected to the drain and a negative terminal of the battery is connected to the gate. Okay, so this is the operation of N channel JFET. This is the circuit. Okay, first we will see different conditions when VGS is equal to 0 and VDS is equal to 0. That means this voltage gate to source terminal voltage is 0 and drain to source terminal is voltage is 0. Then what happens? This is first condition. When VGS is equal to 0 and VDS is equal to 0, what happens? When no voltage is applied, VGS is equal to 0 and VDS is equal to 0 means no voltage applied between drain and source and gate and source. So the thickness of depletion region around the PN junction is uniform. So the thickness of PN junction. So whenever no voltage is applied, nothing will happen. So this junction N channel will be uniform. Okay. So this is look like this one. So there is not change at all. When VGS is equal to 0 and VDS is equal to 0. So now we will go for second case. When VDS is equal to 0, VDS means drain to source voltage and VGS is decreased from 0. So VDS is equal to 0, drain to source and VGS is decreased from 0, that is -1, -2, -3 like that. What happened? So in this case, PN junctions are reverse bias. So you can see. So in this figure, whenever VDS is equal to 0 and VGS increases, there is a formation P and N means there is a junction. So the junction will be reverse bias. So hence, whenever reverse bias is, the thickness of the depletion region is increases. We see in the diodes and transistor. Whenever reverse bias, the depletion region width is increases. Similarly, here also depletion region width is increases because VDS is equal to 0 and VGS we are decreasing from 0 to -1, -2, -3 like that. So depletion region is also increases. So as VGS is decreased from 0, what happens? The reverse bias voltage across the PN junction is increased. Okay, and hence the thickness of the depletion region is in channel until two depletion regions makes contact each other. So in this condition, the channel is said to be cut off. The value of VGS which is required to cut off the channel is called as cut off voltage. So I will explain here. So what is second condition? When VDS is equal to 0. So when VDS is equal to 0 means drain source voltage 0. VGS is equal to from decreasing from 0 to -1, -2, -3 like that. So what happened? See what happened? this channel width is whenever reverse bias, so this channel is increases means depletion is increases. So there is at some moment there is both P and both P type materials are contact each other. Thus that condition we call it as pinch off voltage. That condition we call as pinch off voltage or cut off voltage. Okay, when VGS is decreased from 0 to -1, -2, -3 like that, so it is in reverse bias. Reverse bias means depletion rate is increases, this is increases. At some point of time, both are contact each other. That point we call it as pinch off voltage, VGS off. That point VGS off. We call it as VGS off. So next we will see third condition. So when VGS is equal to 0 and VDS is increased from 0. Okay, VGS is equal to 0 and VDS is increased from 0. Here also same thing we will see. Drain is a positive. Drain is a positive because it is the positive terminal is connected to the drain. Drain is a positive with respect to the source. Okay, VGS is equal to 0. Now the majority charge carriers, electrons, flow through the N channel. Okay. So this is the positive terminal. Positive terminal is connected to the drain. Now the majority charge carriers, electrons, flow through the N channel. Flow through the N channel from source to drain. Understood? Already this is the N-type material, here also N-type material. So this negative terminal is connected to the N-type material. It is having negative electrons. This is also electrons. Electrons some ripples means these electrons are flow through drain from source to drain. If electrons movements are from source to drain means current flow is from drain to source. Okay. Because of the resistance of the channel, the applied voltage VDS, there is a gradual increase of positive potential along the channel from source to drain. See, I repeat, concentrate. So negative terminal is connected to the N-type bar. So N-type bar having negative electrons. This is also negative. So negative is also negative means electrons ripples here. So ripples means these electrons movement is towards the drain. If electron movements is towards the drain means current conduction is towards the source from drain to source. That current we call it as a drain current. ID. That current ID flows from drain to source. Okay. As VDS is increased, as VDS means drain to source voltage. Drain to source voltage is increased, the cross-sectional area of channel will be reduced. We are increasing VDS, this cross-sectional area is also increases. Cross-sectional area is also increases. So the channel width is reduced. At a certain value of VDS, the cross-sectional area at B, this is the B, becomes minimum. Cross-sectional area becomes minimum as we are increasing VDS. Cross-sectional area is decreased. So at some point, it is very minimum. So at this voltage, the channel is set to be pinch off. At that time, that voltage we call it as pinch off voltage. Okay, the channel is set to be pinch off, and the corresponding VDS is called as pinch off voltage or VP. Pinch off voltage or VP. As a result of the decreasing cross sectional of channel with the increased VDS, we will see the following graph. So whenever what is our condition? VDS is increased from 0. from 0 here. See, this is the VDS. VDS is increased from 0 to some value. So whenever VDS is increased, ID current is also increased up to some point. After that it is constant. Okay. After that it is constant. So up to this point we call it as a ohmic region. This region is called a ohmic region. So this region, pinch off region means there is no gap, there is no channel. It is channel is minimum. That channel is minimum means this is the so whenever increasing VDS, this channel width is reduces up to B point is minimum. This voltage we call it as VDS voltage, we call it as pinch off voltage. So that region we call it as pinch off region. So this is the pinch off region, ID current. After that, again we are increasing VDS, some breakdown occurs. Breakdown occurs means this voltage is suddenly increases. ID current is suddenly increases at this point. Okay. So this is the characteristics of N channel JFET. This is the characteristics of N channel JFET. Okay. I will summarize today our class what we discussed. So FET is a field effect transistor. These are two types. One is JFET, junction FET, and other one is metal oxide semiconductor FET or MOSFET. Okay, so MOSFET can also be called as IGFET. IGFET means insulated gate metal oxide semiconductor FET, and MOS, metal oxide silicon transistor. So JFET can be categorized into two types. One is N-channel JFET and other one is P-channel JFET. Similarly, MOSFET can be categorized into two types, depletion mode, and other one is enhancement mode. So we see in JFET. So what do you mean by JFET? It is a junction field effect transistor which is having two types, means N channel and P channel. So construction wise we will see, and also symbols also we see. So JFET in N channel, the conventional current direction is towards the bar, whereas in P channel the conventional current direction is out of the bar. So that is the main difference. So the main difference between FET and BJT is in FET current conduction is takes place only majority charge carriers, whereas in BJT current conduction is takes place majority as well as minority. So FET is a voltage control device, whereas BJT is a current control device. Okay, and also we see operations of N channel JFET. So we have taken different conditions. One is if VGS is equal to 0 and VDS is equal to 0, what happen? We will see. So nothing will happen when voltage is not given. Nothing will happen. Channel is as it is. Whenever VDS is equal to 0 and VGS is increased from 0, like -1, -2, -3, like that, channel width is increases because P and N materials are in a reverse bias. So depletion width is increases. If depletion width is increases means channel width is reduces. So that is second condition. Third condition is VGS is equal to 0 and VDS is increased from 0, like 1, 2, 3, like that. So we can see whenever VDS is increased means ID is increases. ID is increases means, so up to some level we have created some ohmic region. After that one pinch off region, then breakdown region. So pinch off region occurs means this channel width is decreases. At some point of time there is no gap, there is no channel. So that corresponding voltage VDS we call it as pinch off voltage. Okay, the pinch off voltage VDS pinch off or VP pinch off voltage. So at pinch off voltage current is more. After that again we are increasing VDS, current is ID current is suddenly increases. That condition we call it as breakdown voltage. Okay, this is called N channel JFET. So this operation is similar to p-channel JFET also. Okay. Okay, thank you.